To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, children. Now we are going to start the next chapter of this lesson. Do you remember what we learned in the previous chapters? We learned about formation of shadows and different parts of the shadows we learned. And then we learned about the reflection by plane mirrors and the features of the images formed by plane mirrors. Even in this chapter, we are going to learn more about plane mirrors. So we are going to start with the topic multiple images. What is the meaning of multiple images, children? We'll go through this. To show the number of items as increased in jewelry shops, plane mirrors are kept behind the items and parallelly on either side. Right? Light is reflected by those mirrors and a large number of images can be observed. Not only jewelry shops, children. Sometimes you can see even in supermarkets, just behind the fruits and vegetables also plane mirrors are kept. So that number of items look like they are increased, more items present. Right, children? So in jewelry shops also, the jewelry look very beautiful when they are placed in front of number of plane mirrors. Okay, children? In between the plane mirrors, then more number of images can be seen. Right? When we go to salons also, sometimes you can see number of mirrors are placed at angles. Right? When we go in certain elevators also, we can see the elevators apart from the door side, from all the other sides, mirrors are fixed so that you can see many images of yourself. Okay, children? So sometimes when we go to a certain shopping malls also, we can see a large number of mirrors are fixed so that it beautifies the environment by reflecting the same item by many times. Okay, children? So this is known as multiple images. So what actually happens here? Let's see. When two or more plane mirrors are kept at an angle or parallel to each other. Right? When we take two plane mirrors, there's a certain way, two ways that we can keep with each other, right? We can place them with a certain angle. Let's say that this is one mirror, this is the other mirror. Right, children? So we can place the two mirrors like this. So we can place them parallel to each other. So in salons, sometimes you see these type of parallel mirrors. So that when you go stand in between these two mirrors, you can see the front and back of your hairstyle very clearly. Right, children? So here what happens? When two or more plane mirrors are kept at an angle or parallel to each other and an object is kept in between. Now, when an object is kept here or here, you can see more than one image. If you use only one plane mirror, you can obtain only one image of the object. But when you do this, you can obtain more than one image. Okay? So between more than one image are formed. Such a formation is known as multiple images. When two or more plane mirrors are kept at an angle or parallel to each other, and an object is kept in between, more than one image are formed. Such a formation is known as multiple images. Why do we have to use these multiple images, children? Now, as I told you all, in shopping malls and even in supermarkets, when mirrors are placed like this, it looks as if more number of items present, even in jewelry shops. Right, children? More number of items present, and in a way it's beautiful as well. Right, children? And when we consider shopping malls sometimes, and even in hotels, when we fix different large number of mirrors like this at an angle, because they keep on reflecting light, it lights up the environment too. Right, children? So when you consider the jewelry shops, in a way, in order to protect your jewelry from thieves and all also, it's a good measure. That is because when you use parallel, let's say that if you use two parallel mirrors, you have to display only a few items. Okay, all the other items you can keep somewhere safe. Only a few items can be displayed. So even with few items, because you use two parallel mirrors, you can show that more number of items present. Right, children? So therefore, there are different purposes to beautify the environment. Likewise, there are different purposes of using this formation of multiple images. It depends on the place. Okay, children? We'll move on to the next. So we have to do this activity to understand more about these multiple images, formation of multiple images, right? Studying further about the formation of multiple images, right? What do we need here? We need a candle, two plane mirrors and a protractor, right? Let's write. A candle, two plane mirrors. It's better to take them in similar size so we can fix them easily with the tape. Two plane mirrors and a protractor to measure the angle. Right, children? So how to do this activity? Right, look at this one. The method, we will label this. Two mirrors. Plane mirrors. Keep two plane mirrors at an angle of 40. It's not 40, it should be 90. Right? Keep two plane mirrors at an angle of 90 degrees as given here and place a lighted candle between them, right? So first of all, using the protractor, you can measure the angle and you can place the two mirrors according to that angle, and then you can remove the protractor and then you can place a lighted candle in between these plane mirrors, and then you can count how many number of images are formed. Okay, change the angle between the plane mirrors to 60 degrees, 45 degrees and 30 and count the number of images formed in each instance. Even this activity, if you can find two pieces of plane mirrors, even this activity you all can try at home very easily. Okay, children, tabulate your observations. We have to change the angle between the two plane mirrors, and each time we have to count the number of images of the candles formed. Okay, children, let's do this activity now. Right, children. Now we are going to observe the multiple images formed by plane mirrors. Right. So to observe this one, here I have two plane mirrors. I have fixed together those two together with tape. Right. And I have a candle. And you all can see here I have a sheet with all the angles marked. Right. So first of all, we need to place these two plane mirrors at an angle of 90 degrees. Okay. Look here, I'm going to take this one. This is the 0 line, then 90 degrees line. So I'm going to place it like this. And then we need to light the candle. Right. Now I'm going to place this candle here. So multiple images means when plane mirrors make more than one image, that is known as multiple images. So under this one, this activity we are going to observe whether the same number of images are formed when the angle between the two mirrors are changed. Okay, right children. Now can you see how many images are formed? You all can see very clearly 3 images are formed. Now this is the candle, and apart from the candle you all can see there are 3 images formed using these 2 mirrors. Okay. Now next we have to change the angle to 60 degrees. So starting from the 0th line, 10, 20, 30, 40, 50, 60. Right. And now we are going to place the candle. Right children. Right children. Now the angle between the two mirrors is 60 degrees. Now how many images you can see children? Try to count. There are 5 images if you observe carefully. Right. So this is the object. So apart from that you all can see there are 5 images formed. Okay children. Try to count them. It's very clearly you all can count it. Right. Now we are going to change the angle to 45 degrees. So half of 90 is 45, which means this line. Right. Right children. Now I have placed the candle between the two mirrors at an angle of 45 degrees, but at the moment you cannot count all the images because you can't see all the images at once. Therefore, I am going to rotate this little by little and you can count it very easily. Right. So this is the object. Starting from this side, let's count. Right. So at the moment I can see 1, 2, 3 images. 4, 5, 6, 7. Right. There are 7 images formed. Now earlier how many images formed when the angle was 90 degrees between the two mirrors? Only 3 images. Right. When the angle was 60, it was 5 images. Right children? So when the angle is 45 degrees, it is 7 images, which means when the angle between the two mirrors decrease, what happens to the number of images formed children? The number of images formed increase. Now finally, we are going to observe with 30 degrees. Now starting from the 0th line, 10, 20, 30. Right. Okay children. Now again, we can't see all the images. Therefore, I will rotate this slowly. Try to count how many images are there. Okay. So we are going to start from this side. Okay. We can see 1, 2, 3 inside, 4, 5, 6, 7, 8, 9, 10, 11. Right? How many images are there children? There are 11 images. So it's very clear that when the angle between the two mirrors decrease, the number of images increased. Okay children? So when two mirrors make, because when the two mirrors are placed at an angle and when they make more than one image, that is known as formation of multiple images. Right children? So you observe that activity. What did we do? We placed 2 plane mirrors according to different angles with 90, 60, 45 and 30 degrees. What did you observe? More than one image were formed, and each time when you reduce the angle, when you decrease the angle, what happened children? more number of images were formed. Okay, we'll write down. Now, do you remember this one, how many images were formed? Now, let's write it for now. I will show you another way to find out the number of images formed according to the angle. Okay, so the angle between the two plane mirrors, when it is 90, how many images were formed, children? 3. When it was 60, 5 images were formed. When it was 45, how many? 7 images were formed. And when it was 30, 11 images were formed. Right, children? So what is the conclusion? When you decrease the angle between the two mirrors, the number of images formed is increased, right? When the angle between the two mirrors is decreased, the number of images formed increases. Right, children? When the angle between the two mirrors is decreased, the number of images formed increases. Right, children? Compare your observation with those in the table below. Yes, when the angle was 90 degrees, 3 images were formed. When it was 60, 5 images were formed. When it was 45, 7 images were formed. And when it was 30, 11 images were formed. Now, how to memorize all these things, children? Can we even memorize these things? It's very difficult. Now, these are just figures. It's difficult to memorize these things like this. Is there another way to find this out? Even though in this here it's not given, there's another easy way to find out the number of images formed according to the angle between the two plane mirrors. Okay, I'll show you. Right. Now, here there's a simple formula. The angle, the number of images formed. The number of images formed is equal, now this is how you do this, 360. Now 360, you can consider the total angle of that circle is 360. It should be divided by the angle between the two mirrors. Right. Should be divided by the angle between the two mirrors. Minus 1. I'll show you how to calculate using this. If you can memorize this simple formula, it's very easy to count the number of images formed. Right, children? The number of images formed equals to 360 degrees divided by the angle between the two mirrors minus 1. Right? We will start it off with 90 degrees. We will substitute these values and check whether we can get the same value. Right? So, according to this one, let's consider 360 divided by, let's say that the angle between is 90 degrees minus 1. right? You can cut this 0 to this 0 when you consider how many 9s are there in 36? 4. So 4 minus 1, 3. Look at this one. The number of images formed is 3 when the angle between the two mirrors is 90. Right, children? Let's take 30. Right. Let's take 30. In this case, 360 divided by 30 minus 1. Right. So see, 0 to 0 you can cut. 3 into 1. Here 12. 12 minus 1, 11. Look at this. When the angle between the two mirrors is 30, the number of images formed is 11. So as I told you all, you don't have to exactly memorize these values, right? These are just figures. You don't need to memorize. If you can just memorize this formula. Using this formula, even though any other value apart from these values given here, now here given only 4 angles, 90, 60, 45 and 30. But using this one, whatever the angles given in the question, you can find the number of images formed. Okay, children? So try to memorize this one. Anyway, you are going to learn this formula in the upper grade. So it's very easy if you can memorize it from now itself, right? It's easy to do the calculations then other than memorizing a set of figures like this. Okay, children? Let's move on to the next. Right, we have this assignment to do. Observe the number of images formed when the angle between two plane mirrors are decreased. Now we already discussed this, right? So now we know that when the angle between two plane mirrors are decreased, what happens to the number of images formed? The number of images increase, right? The number of images increases when the angle between the two plane mirrors are decreased. Okay, children, we discussed about this. Mention the number of images formed or the nature of images when an object is kept between the two parallelly placed plane mirrors. Some of you must have observed this too, right? Let's say if two plane mirrors are kept parallel to each other, right? If two plane mirrors are kept parallel to each other. Now these are the two plane mirrors. If they are parallel to each other, now let's say if this is the object in the middle, let's consider this is the object, right, children? What happens if we consider this is mirror 1, this is mirror 2? Let's consider the first image is formed by mirror 1, right? So the image is formed on this mirror. When you consider this number 2, this also makes an image of this object. This is object. Let's consider this is image 1, I1. This is image 2. Now here, when you consider this mirror, now this image becomes an object to this mirror, right? This image becomes an object to this mirror. Therefore, another third image is also made here, I3. Now, when you consider this mirror, these both images become objects to this mirror. Right, children? So you can now imagine what's going to happen. It keeps on happening. I4, I5. Right, children? Now when you consider these three images become objects to this mirror, right? So this is going to keep on happening when two plane mirrors are parallel to each other. How many number of images do you think will form? So in this case, infinite number of images are formed because whenever an image is formed by a certain mirror, it becomes the object to the other mirror. So it keeps on happening by both the mirrors, and therefore you cannot count the number of images formed. It is infinite number. Okay, children. So this is what happens when you stand, or when you stand in between two parallel plane mirrors. Right, children? We'll move on to the next. Multiple images formed by plane mirrors are used in day-to-day life. Find out and report several such instances. We already discussed some of these instances before, right? Let's write in jewelry shops. Jewelry shops. In supermarkets. Supermarkets. In salons and dressing rooms. Dressing rooms. Salons. Elevators. Right? To make kaleidoscopes also normally we use 3 plane mirrors. We are going to learn how to make a kaleidoscope later, right? So to make kaleidoscopes, there are many other instances. Right? In jewelry shops, in supermarkets, in dressing rooms and salons, in elevators, to make kaleidoscopes at shopping malls and hotels also. You can write many other examples here. Right, children? So we are going to watch a video related to this multiple images. Right, children? I hope you enjoyed that video. We'll move on to the next. Right, instances where plane mirrors are used. There are so many instances that we use plane mirrors, okay? As mirrors in dressing rooms, this is the main use. Day-to-day life, we use plane mirrors to look at our mirror and in the dressing rooms, okay? To illuminate various objects in cinematography, to direct light, we use plane mirrors, okay? So to direct light onto the slide of microscope. So in the next lesson, we are going to learn about microscopes. So in the microscopes, we are going to learn about compound light microscopes. In the compound light microscope, we can observe a specimen using a beam of light. In this case, we have to direct a beam of light towards the specimen. Specimen means the object that we are going to look through the microscope. So in order to direct light, there's a small mirror. It is a plane mirror, right? One side is plane mirror, okay? So to direct light onto the slide of microscope and to construct kaleidoscopes. Now next we are going to learn how to make a kaleidoscope, okay? And to construct periscope. So after learning the kaleidoscope, we are going to learn about periscope as well. So apart from these instances, what are the other instances that we use plane mirrors, children? In some toys, plane mirror pieces are there, right? Even some jewelry, special types of jewelry also made with some pieces of plane mirrors, right? Sometimes to decorate certain places, certain equipment, we can use pieces of plane mirrors as well, okay? Right, we'll move on to the next. So as I told you all, now we are going to learn how to make a kaleidoscope, okay? So what are the things we need to make kaleidoscopes? So we learned that to make a kaleidoscope, we need plane mirrors, right? So we need 3 strips of plane mirrors. Those 3 strips of plane mirrors should be similar, equal in dimensions, right? So 3 similar strips of plane mirrors. And we need to fix these plane mirror triangularly, and we need to cover them with black paper, Okay, so we need black paper and gum tape too. Let's write 3 similar strips of plain mirrors. Black paper. Gum tape. Right? 3 similar strips of plain mirrors, black paper, gum tape. Let's see how to do this activity. Right. So you have to make this object like this. You have to place the plain mirror like this. Keep the strips of plain mirrors triangularly as shown in the figure. So as you use similar strips of plain mirrors, when you place this triangularly like this angle, each angle should be 60 degrees. Okay. Keep the strips of plain mirrors triangularly as shown in the figure. Cover one end with a piece of tissue paper. So you have to cover this one, and you have to cover the mirrors with black paper, and you have to fix them with gum tape. And one side of this triangular, one side should be covered with a tissue paper. Cover one end with a piece of tissue paper. Cover the mirrors with black paper and stick them securely with gum tape. Okay? Put small colored items like beads, flower petals, and colorful pieces of paper, right children, into this and observe through the open end. Turn round the instruments to see how the colored patterns change. So it's very easy to make a kaleidoscope like this, and I'm sure if you can make your own kaleidoscope, you are going to enjoy this kaleidoscope very much. We'll see how to make this kaleidoscope. Right children, now we are going to observe a kaleidoscope. Now I explained you all how to make a kaleidoscope, okay? Now here I have a kaleidoscope that I have made before. So how to make a kaleidoscope, children? We need 3 strips of plain mirrors. Now if you can't find plain mirrors, you can even find plain glass as well. So what we have to do is, we have to arrange them like a triangle like this. You all can see. So the angle should be 60 degrees. Right angle between 2 mirrors should be 60 degrees. Then you have to cover the outer part of this kaleidoscope with black paper, and here you all can see with tape I have fixed it well. Right children? And now one side of the kaleidoscope you have to cover. Okay? So our instrument is ready. Right children? So why do we use the kaleidoscope, children? So we can use the kaleidoscope to observe different patterns. So when we put colorful flower petals and beads and other colorful pieces of paper, we can observe beautiful patterns inside the kaleidoscope, right? So I will show you. Now here I have some rigiform balls. I will put a few of them into the kaleidoscope. Check whether you can see this. Right. So you all can see the reflection of these small rigiform balls made from 3 sides, because we use 3 plain mirrors. Right children? So here beautiful patterns made inside the kaleidoscope. So because of that, kaleidoscope can be used in, because it makes different beautiful patterns. It is used in textile industry to design different patterns, right? Textile industry, floor tiles and wall tile industry also it is used. Right children? So I showed you all how to make a kaleidoscope. So when you put different colorful items to the from the open end of the kaleidoscope, and when you look through the open end, you can observe beautiful patterns. Okay, so observation when look through the open end, various patterns could be observed. When looked through the open end, various patterns could be observed. Okay, you'll be able to observe various patterns. These patterns are formed by the reflection of light from several mirrors. There are 3 mirrors, so multiple reflection takes place, right? Vivid patterns formed in a kaleidoscope are used to create designs for textiles, floor tiles and wall tiles. Okay, so in tile industry, in textile industry, kaleidoscopes are used to make special patterns. Okay, so here vivid patterns formed in a kaleidoscope. Let's move on to the next. Right, so the next activity is how to make a periscope. Okay, so to make a periscope, we need 2 similar plane mirrors. Now earlier to make kaleidoscope, we need 3 similar plane mirrors. Here we need 2 similar plane mirrors. And the body part of the periscope we are going to make with cardboard sheets. It's good to use thick cardboard sheets, okay, and gum tape, right? Let's write 2 similar plane mirrors. Cardboard sheets. Cardboard sheets, gum tape. Right? 2 similar plane mirrors, cardboard sheets, gum tape. Right? So what is the method? Now you have to make the setup. Now as I told you all, this body part, this structure you have to make with cardboard by fixing the cardboard sheets. And now what are these 2 parts? They are the plane mirrors. Plane mirrors. Plane mirrors. Make tubes of appropriate size using the piece of cardboard sheet to construct the equipment as shown in the above figure. Right? Place the pieces of mirrors at an angle of 45 at each bend. Now when you consider, this one should be 45. I'll draw a big mistake. I'll draw a bigger diagram to show this. Let's consider. So, if this is the periscope, let's consider this end is this. This is the plane mirror. This side is the good side. This is the back of the mirror. Right, children? And this should be fixed at right angle, and this is 45 degrees. This is also 45 degrees. Okay, children? And the next one, this one also should be fixed in the same way. Right, children? So observe objects through the instrument you made. You have to place your eye here and you have to look through this instrument. Okay, children? We'll see how to make this instrument now. Right, children? Now I'm going to show you all a periscope. Now here, previously made periscope, I am going to show you all. I already explained you all how to make a periscope. Okay, so you can using S-lone pipes, using cardboards, we can make these type of periscopes. The speciality is periscopes has two plane mirrors fixed inside. Now in the periscope, we can't see the plane mirrors. Now the plane mirrors are fixed at these two bends, one over here and the other over here, right? So when we fix the periscope, you have to fix it in a certain way. The angle between the bend and the periscope should be 45 degrees. Here also it should be the same. Okay, children, in that case, the two plane mirrors are parallel to each other. Right, children? Okay. So what is the importance of the periscope? Periscope can be used to observe some place that we cannot see, a certain higher elevation we can observe using the periscope. Right, children? So in that case, we have to place our eyes like this, and so we can observe somewhere upper elevation using the periscope. In that case, what happens? Now here, this is the upper part, this is the lower part that we place our eyes on, right? So when we observe something using this periscope, so we are going to place our eyes. This is where we look into. We are going to look from here, and the light rays coming from that particular object enters this periscope from here. Right, children? And then those light rays will be reflected by the first mirror. And the reflected light rays will directed to the second mirror. And from that mirror also those light rays will get reflected and then reaches our eyes. So in that case, because of this double reflection of the light rays, we can see the image. Okay, children? So check whether you all can see the small mirror fixed inside. So if you observe carefully, you can see the mirror inside shines. Okay, children? Right. So using the periscope, we can observe an upper elevation where we cannot see. So because of that, we can use periscopes in submarines. So when the submarine is in the water, inside the water, which means underwater, the people inside the submarine can see out of the water using these type of periscopes. And also periscopes are used in bunkers too. So you observed that, and I hope it was very clear. Now what did we do? We learned how to make a periscope, and when you make the periscope, you have to fix these two plane mirrors at an angle of 45 degrees at the bend. Okay. So what is the importance of periscope, children? You can use this periscope to observe something, a certain object at a higher level than that of your eye level. Right, children? So let's say that if you are going to observe somewhere here, tree, or let's say most of the time these type of periscopes are used in submarines, right? So let's say if the submarine is underwater, to observe something above the water, you can use this type of periscope. Right, children? So here, the light rays coming from that object at a higher level first reaches the first plane mirror, and then the image is formed here. So the image formed on this first mirror becomes the object to the second mirror, and the image formed here on the second mirror can be observed by yourself, right? Now here you have to place the eye somewhere here. The eye level should be here. But when you observe, you are going to observe an object at a higher level than that of your eye level. Okay, children? Let's write. You can observe the objects at a higher level. That's right, than that of the eye level. You can observe the object at a higher level using a periscope. Right, children? You can observe the object at a higher level, objects at a higher level using a periscope. Right, children? We'll move on to the next. Right. An observer positioned at a low level can use a periscope to observe incidents that occur at a higher level. So what are the examples? What are the instances where these periscopes are used? I already explained you in submarines. Right? Not only that, in bunkers. Now bunkers present underground. So when you're underground, if you want to observe something take place above the ground, you can use these type of periscopes. Okay, in bunkers. What else, children? In submarines, in bunkers, and also in armored vehicles. Right, in armored vehicles and tanks, like these type of armored vehicles and tanks are used in war situations. So when you are inside these type of armored vehicles, in order to observe outside, you can use a periscope like this, right? Armored vehicles, in submarines, in bunkers, in armored vehicles and tanks. Periscopes are used. And also in nuclear power plants also periscopes are used. Why, children? So you all know that when nuclear reactions take place, a lot of harmful substances are released. Okay, children? Therefore, in order to observe these reactions, we can't go very close. In that case, we can observe the reactions, whether it takes place properly, using the periscopes. Without going closer to those chambers, we can use periscopes to observe the reactions. Okay, therefore, in nuclear power plants. Okay, children. So these are some of the uses of periscopes. You can find the other ways as well. Okay, children. Right. We'll move on to the next. So this is the last topic of the lesson, children. Right? Images formed by curved mirrors. So far we learned about umbra and penumbra, which means the shadow formation. And we learn about the images formed by plane mirrors as well. So this is the last topic, images formed by curved mirrors. Right, children? So what are these curved mirrors? Now we are very familiar with the images formed by plane mirrors. What are the features of them and all? Because even day-to-day life also, most of the time we use these plane mirrors. Right? Look at these pictures. What is this? This is a spoon. Right? So some objects with curved surfaces. Right? Some objects with curved surfaces. When you see now, this is a spoon. So when you take the spoon, one side of the spoon is curved outwards. Right? Let's take the cross section of a spoon. If this is the spoon, so if you look from the side, if this is how it is, this surface is curved outwards. These type of surfaces that are curved outwards are known as convex surfaces. Right, children? So this is a convex surface. What about this surface? That surface is curved inwards. These type of surfaces are known as concave surfaces. This side is convex. This side is concave. Right, children? So here, have you ever seen the image of your face on a metal spoon? If you haven't, you can do this activity at home. Right, children? The image is seen differently on the inner surface and on the outer surface. Now, outer surface means convex surface. Inner surface means concave surface. if you look carefully through these convex and concave surfaces, you will see the images formed are different, right? Now, when you consider these metal spoons, they have a polished, shiny, smooth surfaces, which means they also can act as mirrors, right, children? That is why you can see your image through these surfaces, okay? So, look at these two pictures, children. Now, this is the convex surface, which means this side of the spoon. This is the concave surface, which means the side that is curved inwards. You all can see when you look through this side, upright image is formed here. What about this image? That is an inverted image, which means upside down image. Okay? So, even though it is the same spoon, because it has two different surfaces, images formed on these curved surfaces are also different. Okay, children? What is this? This is a watch glass. When you consider the watch glass also, it has convex and concave surfaces. Now, this inner part is known as the concave surface, outer part is convex surface. Right, children? So, this happens because of the surfaces of the spoon act as curved mirrors. So, what are these curved mirrors? Let's see, children. Mainly, there are two types of curved mirrors named convex mirrors and concave mirrors. Now, I already explained you all about convex and concave surfaces. Right? When you consider convex surfaces, they are bulged outwards. Right? Concave surfaces, they are curved inwards. Right, children? Right. So, mainly there are two types of curved mirrors named convex mirrors and concave mirrors. The reflecting surface of a concave mirror is curved inwards and that of a convex mirror is curved outwards. Look at these pictures. So, when you consider the concave surface or concave mirror, the reflecting surface is curved inwards, right? So, this is the front of the mirror. This is the front of the mirror. This is the back of the mirror. When you consider the convex surface, what happens? The reflecting surface is curved outwards. Therefore, this side is the front. This is the back of the mirrors. Now, you all remember when we draw the plane mirror, we draw a straight line like this. And the back of the mirror is indicated by these small lines. Right? The front of the mirror is indicated by this other side. Okay, in the same way, the side with these tiny lines indicate the back of the mirror. Okay, children, even in the curved surfaces. Right? We'll move on to the next. Right. So, when we discuss about these mirrors, curved mirrors, plane mirrors, we always have to discuss about light rays and light beams. Now, you all have already learned about these light rays and light beams. What is the meaning of a light ray, children? A light ray means a narrow path of light. How do you indicate a light ray? A straight line. So, not only the straight line, you have to show the direction as well. Why do you always have to use a straight line to indicate a light ray, children? That is because light always goes in straight lines, okay, or straight paths. Therefore, you always have to use a ruler to draw a light ray, okay? And what about a light beam? What is a light beam? Now, light ray is a narrow path of light. Light beam is a collection of number of light rays. Okay, children? Right. A ray of light is denoted by a straight line and the direction is indicated by an arrowhead drawn on the straight line. We have done that before. A beam of light is made up of a bundle of light rays. A bundle of light rays. Okay, children, right. Ray of light. We will draw a ray of light here, a light ray. And we have to draw the direction using the arrowhead like this. So if you don't draw this arrowhead, if you draw only the straight line, it is not correct, children, right? So you must show the direction as well, okay? And then when we consider the beam of light, there are different beams of light. A beam of light means a bundle of light rays, which means a collection of light rays, right, children? So when we, there are three different types of beams of light. What are they? Parallel beam, diverged beam, converged beam. What is the meaning of a parallel beam? Here all the light rays are parallel to each other. All the light rays are parallel to each other and they move to the same direction. Therefore, when you put the arrowheads, you have to put the arrowheads to the same direction. Right, children? So this is a parallel beam of light. What is the meaning of diverged beam of light? Diverging. They scatter away. Right? So here what happens? So the light rays starting from the same point and they spread out. They move to different directions, but they all start at the same point. So this is how you draw a diverged beam of light. You have to draw the lines that scatter or spread out starting from one point, and not only that, you have to show the direction also, otherwise it is wrong. Diverged beam of light, right? These type of light beams, all the light rays starting from one point and they spread out. Right, children? Converged beam of light. What is the meaning of converged beam of light? It is the opposite of this diverged beam of light, which means light rays coming from different directions, they collect at the same point. So how to draw this one? The same thing. Now we can draw the same thing and we can put the arrows to the other direction, opposite direction, right? We can draw the same type of light beam like this, only the direction changes. Here you all can see starting from the same point, these light rays, they spread out, they move to different directions. Here, starting from coming from different places, these light rays are collected at the same point. Right, children? So ray of light means a narrow path of light, right? Parallel beam of light means any beam of light means a collection of light rays or bundle of light rays. Parallel beam of light, all the light rays are parallel to each other, right? Diverged beam of light, light rays starting from one point and they spread out. They go to different directions, right? Converged beam of light, coming from different directions, all the light rays gather or collect at the same point. So in each instance, it is a must to use a ruler to draw straight lines, and it is a must to show the direction using an arrowhead. Otherwise, these light rays or light beams are not correct. Just a few lines, straight lines, they are not correct. You have to show the directions as well. Right, children? So why did we learn about these converged beam, diverged beam, parallel beam and all, children? Because when we learn about these curved mirrors, the knowledge of these different types of light beams are very important. We'll move on to the next. Right. So we are going to learn about the concave mirrors now. We have an activity to do. Testing what happens when a narrow parallel beam of light falls on a concave mirror. Now we know what is the meaning of a parallel beam of light. This is how we draw that, right? So light rays that are coming, a light beam that is coming towards a mirror, where the light rays are parallel to each other is known as a parallel beam of light. Okay. So to do this activity, we need a concave mirror, a plane mirror, and we need a torch. Right, children? Okay, it's better if we can find a laser beam torch. So in that case, it's very easy to observe. Okay. A concave mirror. A concave mirror. What is a concave mirror, children? The mirror surface is curved inwards, okay, like this. A plane mirror. So if we have a good laser beam, even without a plane mirror, we can do the activity, right? A laser beam torch. Right? A concave mirror, a plane mirror, a laser beam torch. Okay. Next one. What is the method? Direct a narrow parallel beam of light onto the reflecting surface of a concave mirror. This can be done by using a plane mirror. You can use a plane mirror to direct this light coming from the torch towards the concave mirror. Okay. Record the observation. So how to do this activity? You have to take the concave mirror. How to draw the concave mirror? This is the concave side. This is the back of the mirror. What you have to do is you have to direct a parallel beam of light onto the reflecting surface of a concave mirror. So parallel beam of light. How to draw that? Like this. Now, is this correct, children? All the lines are parallel, but still this is not correct. Why? Because you have to show the direction using arrowheads. Okay. It's coming towards the concave mirror, right? So direct a narrow parallel beam of light onto the reflecting surface of a concave mirror. Record your observations. Let's do this activity now. Right, children. Now you all know that there are two main types of curved mirrors, convex and concave mirrors. Okay. Now here we are going to observe what happens to a narrow parallel beam of light that falls onto a concave mirror. Now can you all see? This is a concave mirror, children, right? So this mirror is curved inwards, children. So this is known as concave mirror. Okay. So using this device, I am going to direct a parallel beam of light onto this concave mirror. Okay. Now we use the same device when we were learning about the plane mirrors as well. So observe carefully, children. Here. Now you all can see this is a narrow parallel beam of light. You all can see very clearly these light rays are parallel to each other. Now what I am going to do is I am going to place this concave mirror in front of this light beam, right? Observe what happens now. At the moment, these light rays are parallel to each other, okay? Now, look what happens when I place this here. What can you see, children? What can you see, children? You all can see now these angled light rays are the reflected rays. So these light rays go to this direction. When I place this one, what happens, children? These light rays will fall on the mirror and then they get reflected, right? Because when light falls on mirrors, because of the shiny surfaces, they get reflected, okay? So here look at the way it gets reflected. You all can see very clearly that these light rays, these three rays, they meet at the same point, right? See, if I change this mirror like this, the direction of the mirror like this, you all can see they meet at this point, okay? So what happens? These light rays collect at the same point, right? When I remove this one, you all can see it's again parallel. When I place this one, it's very clear that these light rays, all these reflected light rays meet at the same point. They collect at the same point. Right, children? So after doing this activity, it is very clear that a narrow parallel beam of light that falls on a concave mirror collect at the same point. Right, children? So you all observed what happened. What did we do? We directed a parallel beam of light towards a concave mirror like that. What happened, children? Do you remember what happened here? Now, the light rays that came towards the mirror. So after meeting the mirror surface, what happened? They get reflected. After reflecting, what happens, children? They got collected to the same point. Right, children? Right. So we'll draw the parallel beam of light like this. So parallel beam of light came onto the mirror like this. We have to show the arrowheads as well. Then what happens? They meet the mirror surface and they get reflected. We will draw the reflected rays with a different color so that it's very clear. You all observe this now. So they got collected at the same point. Right? They got collected at the same point like this after reflecting. So the blue color lines are incoming rays that are coming here. The pink lines are the after reflecting what happens there. Right? After reflecting, they got collected at the same point. Right, children? Let's write what happened here. Right. The parallel beam of light falling on the concave mirror collects at the same point after reflecting. After reflecting. Right? The parallel beam of light falling on the concave mirror collects at the same point after reflecting. Now look at this beam of light. Now it's coming towards the mirror as a parallel beam of light. Right? After reflecting, what type of beam is created here? Now you all know this type of light beam is known as converging light beam. Right? Converging light beam, which means if light rays coming from different places to the same point, that type of light beam is known as a convergent beam or converging beam. Right? Let's go back to our where we learned that. Look at this one. Converged beam of light. Converged. From different places, light rays coming to the same place. Converged beam of light. Now look at this. Here the same thing happens. Light rays collected at the same point. Right, children? Which means when a parallel beam of light falls on this concave mirror, it turns into a converging beam of light. What is the meaning of this? These concave mirrors can be used to converge light, which means to send light at one point. Right, children? Therefore, these type of mirrors, concave mirrors, are known as converging mirrors. Right? To converge light, it can be used. Therefore, these are known as converging mirrors. Right, children? Let's write this. Conclusion. You write in a different color. Conclusion. Concave mirrors can be used to converge light. In brackets we will write, therefore they are known as converging mirrors. As converging mirrors. Right? Concave mirrors can be used to converge light. Converge light. To converge light. To send them to the same point. Okay? So they are known as converging mirrors. Right, children? We'll move on to the next. Right. Here, you can observe that the light beam collects at a spot in front of the concave mirror. It collects at a spot in front of the concave mirror. Right? This collection of a parallel light beam to a single spot in front of the mirror is known as the convergence of light. Right? Therefore, concave mirrors can be used to converge light. Because of this reason, they are known as converging mirrors. In some books, in some articles, you will read them as converging mirrors as well. Okay? Right. Look here, the same thing we observed, right? Parallel beam of light. These red and blue lines are the parallel beam of lights. Okay? And after reflecting, they meet at the same point, place where the spot of light is formed. Right, children? Okay, we'll move on to the next. Now we are going to learn about convex mirrors. The same activity, we are going to replace the concave mirror with a convex mirror this time. Okay? So test in what happens when a narrow parallel beam of light falls on a convex mirror. We are going to do the very same activity. The only difference is this time we are going to use a convex mirror. So we need a convex mirror, and we need a plane mirror, and we need a laser beam torch, right? Let's write. Convex mirror. So the mirror side is curved outwards. Convex mirror. We need a convex mirror, a plane mirror, a laser beam torch. Right? A convex mirror, a plane mirror, and a laser beam torch. Right? So how to do the activity? The same way as before. Direct a narrow parallel beam of light onto the reflecting surface of a convex mirror. You can do this by using a plane mirror as well, right? Record your observations. So what you have to do? This is the convex mirror, curved outwards. So you have to send a narrow parallel beam of light onto the convex surface of a mirror like this. Right, and the arrowheads. Right? You have to direct a narrow parallel beam of light onto the reflecting surface of a convex mirror. And we have to observe what happens after reflection of light. Let's do this activity now. Right, children. So in the previous activity, we learned what happened to a light beam, a narrow parallel light beam that falls onto a concave mirror. So we are going to do the very same activity, but this time using a convex mirror. So here I have a convex mirror. What is a convex mirror, children? The convex mirror is curved outwards. Concave mirror is curved inwards. Convex mirror is curved outwards. Observe this very carefully. Check whether you can identify the curved surface. Right. Now I am going to do the same activity that I did before. Right. Here we have a narrow parallel beam of light. All the light rays are parallel to each other. What I am going to do this time? I am going to place this convex mirror in front of this parallel beam of light. Okay? Okay, observe what happens. Right. What happens, children? This time you all can see. Now these are the light rays that coming towards the mirror. So after reflecting, what happens, children? They go away from each other. Earlier, what happened, children? Earlier, when we placed the concave mirror, all the light rays after reflection, they collect at the same point. I will show you with the concave mirror again. Look. So after reflection, the light rays, the reflected light rays, they meet at the same point. They collect at the same point. Here, what happens? Here, the opposite happens. After reflection, all the light rays, they move away from each other, they spread out. Okay, children? So, spreading out, this is known as divergence of light. Okay? Now, when we place this concave mirror, they collect at the same point. This is known as meeting all the light rays at the same point is known as convergence of light. Right? So, the opposite of convergence is divergence of light. After reflecting, the light rays, they spread out, they move away from, or they go away from each other. This is known as divergence of light. So this mirror can be specifically used to spread out the light rays. Therefore, this type of mirrors are known as divergent mirrors. Okay? And at the same time, these type of concave mirrors, because we can use this to collect the reflected light rays at one point. These type of concave mirrors are known as convergent mirrors. So you all observed what happened. What did we do? We directed a parallel beam of light onto the reflecting surface of a convex mirror. Then what happened, children? After reflecting, they spread out. All these light rays, they spread out. Right, children? So here, this is the convex surface. How to draw this? This is the convex surface. And we have to draw the back of the mirror as well, like this. We send a parallel beam of light like this. Right. And the direction is towards the mirror, right? So a parallel beam of light is coming towards the mirror. So after reflecting, they will scatter or they spread out. All these light rays, they spread out, okay? But at the same time, if you extend the lines of these light rays at the back of the mirror, you will see they will meet at the same point. Okay, therefore, when we draw this diagram, we have to start from the same place. So here we are going to draw with a dotted line like this. Right, children? Right. Okay. So you have to draw the direction as well. Right, children? So they come as a parallel beam of light, and after reflection, they spread out. Okay, children? They spread out like this. Okay? Right. Let's write. The parallel beam of light falling on the mirror spreads out after reflection. Right, children? The parallel beam of light falling on the mirror spreads out after reflection. Right, children? So look at this light beam, children. Now earlier, using the concave mirror, the parallel beam of light was converted to a converging light beam. Look at this one, the parallel beam of light, they scatter, they spread out. So here what happens? This is a diverging light beam. So the parallel beam of light falling on the convex mirror converts to a diverging beam. So if a certain light beam goes away from, in the light rays go away from each other, if they spread out, that type of light beam is known as a diverging light beam. Okay, children? So what is the conclusion? These convex mirrors can be used to diverge light rays. Right? Diverge light. Therefore, this type of convex mirrors are known as diverging mirrors. Right, children? Let's write. Convex mirrors can be used to diverge light. Or they can be used as diverging mirrors. Diverging mirrors or divergent mirrors. Right, children? Right. Convex mirrors can be used to diverge light or as diverging mirrors. Okay? Right. Here the same thing is given. It can be observed that light which falls on a convex mirror spreads out after reflection. This spreading out of light after reflection is known as the divergence of light. Therefore, convex mirrors are considered divergent mirrors, right? Or divergent mirrors. Look at the same diagram that we drew there. Okay, children. Right. We have completed this chapter as well. So even in this chapter, we learned more about plane mirrors and we learn about convex and concave mirrors as well. Even in the next chapter, we are going to learn more about convex and concave mirrors and the images formed by the curved mirrors.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.